Hi, Claire. And the other person who's in as well? Oh, Eunice, okay. And Sam is here as well. Cool. Um, hey, everyone. What you might as well do is you'll need pen and paper for some of the stuff we're doing. Okay, so three Lewis structures. So do you reckon everyone else is still asleep? Wouldn't surprise me. Oh, nice. We've got a few more people coming in. If you have just arrived, three Lewis structures. Um, and then we'll move on from there, okay? Alright people, I'm going to start throwing together mine, and then we'll move on. Hopefully I won't overtake you. Alright, we're good to check them out. I haven't finished some of these on purpose just because I want to show you the final little bits in a couple of spots. I'll flick on the other camera. Okay. If you're not adding up your valence electrons, then something's going to go wrong. Probably on the last example actually for today. Okay, 16 valence electrons. That's what I've got, but the carbon needs to have 8. But we can make that happen by making some of the lone pairs on the other atoms become shared electrons. So now it's got 8. Okay, could be redrawn. You know, any shared electron pair can become a stick. Okay, so you've got a lone pair there, and then there's another S there, and a couple of lone pairs on that one. It looks a bit tidier with the sticks, but it doesn't actually matter if you do that or not. H2O, easy money really. There's not really much that can go wrong with that one. 8 electrons only, the H's only need 2, so the oxygen gets 2 lone pairs on it. And the last one is this one, and I haven't finished it. Just out of curiosity, has everyone got them 100% right so far? I'm kind of hoping that you have. Type in chat if you did. This also tells me how lagged our stream is, for how long it takes for anyone to reply. Max has all got, okay, right, yeah. Seems like there's still like about a 30-second lag or something like that. I found a setting and I thought I might have made it better, but I don't know if it made a difference, to be honest. Okay. I ran off with some of the mods from school, so we're going to need them in a second. So I'm just tinkering with them in the meantime. All right, last one. I see a problem with the atom in the middle because that sulfur atom only has 6 electrons, and it needs to have 8. And I can't put in any extras because that's not how you do things. Okay, I need to just work with what I've got. And some people get hung up on this because they're like, oh, but which oxygen needs to make a double bond? Does it this one or is it this one? And the fact is it doesn't actually make any difference, because if I make the double bond and go here, that is actually basically the same thing as it's now on the other side. Okay, so there isn't really a left or a right to this. Okay, as long as one of the oxygens get a double and one gets a single, it doesn't matter if I draw the double on the left and you draw it on the right, because I could just pick up my drawing and make it the same as yours. Okay, so the slightly tidier version is this one, right? Alright. Once you get used to Lewis structures, they get really fast, and they kind of actually get, to be honest, like it's like a little bit boring. It's like, is this what we're going to do? Okay, what you're going to be doing today, and like just out of curiosity, has most people, done a decent amount of the assigned work? Just type in chat if you have or not. Yeah, of this week's work. Yeah? Awesome. Okay. Because if we're all in like completely different spots, it's just going to be it's going to make life like quite difficult for me to work out what's going on. Okay. All right. So we're going to think about if the Lewis structure tells us about what the electrons are doing in the atom. We can also take the Lewis structure and then we can work out what the actual shape of the thing might be. Okay. Oh, by the way, I just realized that I forgot to put that pair on there. So for example, you might look at that Lewis structure for the SO2 that I've just drawn and pretty much think it looks a little bit like this, because that matches my Lewis structure. If that's the S, get back here, if that's the S and there's 2 O's left and right, I mean it's all in a straight line, kind of matches the picture actually. In fact, currently this item that I have here actually matches H2O, and it also matches the CS2 as well in terms of the Lewis structures. The thing is that only one of these actually looks like this. The others all kind of have funky angles going on, so we've got to work out why. Okay. Just as an aside before we move on, let me just flick the camera across desktop. Okay, so we are going to use something called, it's got a really fancy sounding name, but it's really quite simple, valence shell electron pair repulsion. We use this to work out the shapes of molecules, and the shapes give you all sorts of information about the properties of it. Okay, I'm gonna quickly just jump into present mode for this, because I've got an example about shapes. The thing about the shapes of stuff is that it does matter quite a lot. Okay, here's an example of it mattering quite a lot. Okay, so this weird looking blob thing, okay, it's actually drawn in 2 different angles and is like, what is going on here? It's a pretty complicated thing. Okay, this is not a simple molecule like what we're drawing. This will have probably around 1,000 atoms in it in total. Okay, It's a protein, but you see how it says right here, it says viral membrane. What this actually is that this is part of the coronavirus spike proteins, and it's a section that allows it to get inside the cells of people to make them infected and cause all the problems that we've got. Okay, and it has a certain shape. And the things we learn about in this topic that control the shape of our little molecules are actually the same things that control the shape of this big thing here. Okay, and then I have a shape here of something which has got, it says here extracellular side, and then down here it says cytosolic side. Cytosolic means cytoplasm. Okay, so this is the thing that's on the outside of some human cells, and this particular green thing, I believe, is actually able to stick on to this little flag thing sticking up here because of their exact shapes. And then the virus gets inside the human cell, and then it causes all the problems that we have now. Okay, but the thing is that they fit together in a certain way because of their shape. But if you knew that shape, then maybe you could do this stuff. Maybe you can make something which actually sticks onto the surface of these parts of the cell, but it sticks on there actually better than the virus does. So you coat the cell in these kind of like little blue markers, and it means that the virus can no longer get in. Okay, and the other option is that you don't worry about trying to coat the cell with something. You actually find something that has the exact shape that sticks to the virus, which is what this sort of thing here is. Okay, and the idea is that if you coat the virus with something else, it's like if you have like a key and it's covered in like you cover like plasticine over it or something, that key is never going to fit into the lock anymore because you've changed its shape by putting all this extra stuff on it. Okay, so this is actually one of the major ways that people are actually finding like new medicines to treat things. Okay, and I want to show you something because I don't know if you guys might be interested in trying this. There's a fair bit of downtime for all of us at the moment. So I found this program just by chance, and it's called Foldit. And what it actually is, it's sort of set up like a game. And what you have is that you have all these little challenges where you need to change the shapes of objects and change what's inside the proteins in order for it to do something. Okay, and it starts off with really easy challenges, and this is the first of the. I've done the easy challenges, and I now have to make the spirally thing, change it to fit on to the grey thing, and the grey thing is actually a coronavirus thing, by the way. Um, and people from all around the world are trying to find things that might actually be useful against the coronavirus. So if you're feeling bored and you've run out of games to play, you could try that. It's called Foldit. It's in a link. It's right there on that side. I don't know. You can actually set up teams, and I talked to the scholarship chemistry people, and I said I would make like a Newlands College team, and the idea is the team gets a team score, and there's like a scoreboard. You can see if we can get on the scoreboard or something. I don't know. I can post a link to it on Classroom as well. Anyways, we need to carry on with shapes. Okay. And this is basically what happens with the shapes. All right, so what I'm going to get you to do is that we need a few Lewis structures to use as examples for this. So I'm going to leave a slide up on here, and I want you to make the document camera will come back on very soon. We will recycle the 3 Lewis structures from before, so I'll add them on, but you don't really have to redraw them because they're already inside your thing. H2O, CS2, NCl. Oops, I did that one twice. H2O. That'll be a good starting list. Okay, so let me flick the camera across. This camera doesn't always focus that well. Oh, actually, we'll go just as I said it. Okay, so turn all them into Lewis structures. You've already done that one, and also SO2. But there are 3 extras inside there that I will get you to take care of. Actually, there might as well be one more, which is going to be a pretty boring one. I might add up one more to make the whole list set at 8. But for now, just start drawing those. And if you've read far enough ahead for shapes, then I guess you might as well try and think about what the shape is. Think about how to actually draw those shapes on a piece of paper. I'm not sure if you would have actually come across that in the SciPad work. And I'll be back with you in about, I'll give you 4 minutes. Has anyone finished? No, has the full set? Just type in chat if you do. No, okay, no, okay. So some people have, some people haven't. Okay, well I'm just drawing them as well. So probably you're probably pretty close. And if you are completely done, it'll only be a couple of moments before I've got them all sorted. All right. If they are all done, I think the next thing to do would be to look at them and think about the electron clouds on the central atom. Okay, so how many different electron clouds are there? Remember, lone pairs are electron clouds and bonds are electron clouds. Electron cloud just means that there's an area and it has electrons inside it. Okay, so some of these will have the central atom only has 2 electron clouds, and some of them it has 3, and some of them it has 4. If you can work out what that number is, maybe just put a note next to them because it will allow us to bundle these together, which is handy for the next step. And the next step is going to come up pretty soon. Okay. Is Miss Brownell and Miss Grant on the stream at the moment? All right. Stuff away. What I have isn't the exact same order as what you've got, but I'm going to start off with these two guys here. Okay, one of them was one of the starter questions, and the bottom one is actually kind of a really boring example because there's only one answer to it. Okay, so that Lewis structure makes the top one look like that, and that's actually going to be correct. Okay, the reason why it's going to be correct is that you have to think about the fact that these areas here, there's a bubble, and it's got 4 electrons because it's a double bond. Okay, but that one bubble is a cloud of electrons. It just happens to be a cloud of 4 electrons, and this is another bubble of a cloud of 4 electrons. And the thing about electrons is that they're stuck in their clouds, and that is the way it is. Okay, so this, I think Miss Grant said that there's going to be balloons here. Oh, right, okay. Yeah, so if you still have a link, it gets saved as an offline YouTube video. Okay, so if this is one electron cloud, that's got 4 electrons inside it because it's a double bond. Okay, and this can be the other one. And these 2 electron clouds are on this atom in the middle. But the thing about the electron clouds is that they are going to repel each other because they've got the same charge. Okay, so if we have these 2 clouds of electrons and they're repelling each other, they're going to push as far away as possible. So if you have 2 clouds, aren't they going to be like exactly 180 degrees away from each other? And that's what it is. Okay, so that first example is going to have those 2 bonds in a perfect straight line. Okay, we'd call it a linear molecule because all of the atoms are arranged in a straight line. Okay, the bottom one, if you've got 2 atoms, then like by default, two things always have a straight line between them. Okay, so if there's only 2 atoms, the structure is called linear, and there's nothing more to add on it. Okay, that this is all it can be. Okay, I want you guys to now think about these guys right here. Okay, the drawings kind of make the top one look like that, which isn't true, and it makes the bottom one look like that. That's going to roll away again, isn't it? Stop there. Which also isn't true. Okay, and the reason why they're not true is that the Lewis structure isn't there to give you the exact shape. We organize the Lewis structure just in a nice orderly fashion, left and right, up and down. Okay, but think about what these 3 things here in CH2O are. This is a cloud of electrons, 2 of them. This is a cloud of electrons, 2 of them, and this is a cloud of electrons, that's 4 of them. And all of those clouds hate each other. So they're going to be pushing away from each other. And I just don't think that having a really sharp right angle here and a really sharp right angle here and then this massive big 180 degree gap is really as far away as they can be. And in fact, if I just get my balloons, two, three. If we just hold 3 balloons sort of close together, they actually make like a triangular shape. Okay, the balloons are pushing against each other now. You can see the, so they're naturally repelling each other away as far away as possible, and that's what the electron clouds are going to do. Okay, so the top one doesn't have the left and right and straight up. It's actually got more of a triangular arrangement. Okay, so if we were to draw it as a real structure, you can have an atom in the middle, double bond to an atom at the top, atom diagonal out the side and diagonally out the side, and 360 degrees all the way around. Each one of these would actually be a 120. 120, 120, 120. We're going to come back to the SO2, but that's not going to be the answer, this one here. And you can probably tell me why, possibly. Let's think about these guys here. Okay, yep, if you guys got physics at 9:40. Okay, the stream turns into an offline video, so you can come back on and watch it if you like. Have fun in physics. So the top one, top left, probably you're thinking it is this. Because I mean, the Lewis structure looks like that, but that's not the actual structure. Okay, and the reason why is that even though you might look at it, and this is where you've got to be, you've got to think more 3 dimensions rather than just flat on a piece of paper. Okay, all these gaps, are 90 degrees. There's right angles, right angles, right angles, right angles. You might say, well, I can't make them go further away from each other than that, but you can if you use 3 dimensions. So one of my balloons has just ran away. I'm just going to go grab it, and then we'll see what 4 balloons held in a bundle will actually look like. Because I don't think it's going to look like that. I think it's going to be more like this. Okay, I've got like the 3 balloons down the bottom, kind of like as tripod legs, and then one of them is actually pointing straight up into the sky. Okay, they're not perfectly, they don't really want to stay like this, being completely flat. If I just let go, they actually just bounce back to how they were before. Okay, so the balloons are pushing away as far as possible. Those 4 electron clouds are going to sit exactly like this. Okay. I can't actually remember if the SciPad had how you draw the bonds in it, but it's like the shape is 3 dimensions, your page is 2 dimensions, so how do you draw it? And the rule is that you can have, let me just go back, you can use triangles for your bonds to show how they sit. Okay, so the way to show the shape I had there would be something like this. Okay, and the idea of that, I can probably try and use this to see if I can get it to work. Oh, sorry, like that. That's the real shape, right? One of those bonds pointing straight up into the sky, then 3 of them are like 3 tripod legs for your camera. Okay, so if I hold this on a bit of an angle over this, what I've got is that I've got one bond pointing towards you guys, one going into my table, and then this one and this one are sitting pretty flat. Okay, so the straight lines are the 2 that are flat. One of them goes behind into the table, and one of them sticking outwards. And the one that gets fatter is coming closer to you because it's like art perspective drawings. I like to put the atom on the end of it bigger as well to make it stand out. And I usually make that atom a little bit smaller. Okay, so that's how you draw that one. Hopefully you've probably seen most of that stuff in your SciPad. I don't know if it's making sort of more sense or less sense, I don't know. I have posted a document on your on Classroom, and it's a thing we usually do in class using plasticine, but you can actually do it with almost anything you can find at home. And if you're a little bit confused about what the stuff looks like, and you want something in front of you to look at, have a look at that activity. It also has a link to an online program where you can build the atoms and build the molecules and spin them around and see them on the screen. Okay, but we now need to go back and think about some of the others. Okay, so those 2 are both linear. Okay, they're sorted. Okay, the top one is sorted. I didn't give it a name. The fact that it's got 3 bonds, so 1, 2, 3, that can be called trigonal. Okay, and also the fact that it's sitting perfectly flat can be described as being planar. So we call that one trigonal planar. Okay, 3 bonds sit flat. SO2, the thing about the SO2 is that what we need to realize is that on the central atom, here, there is 1, 2, 3 clouds. 2 single bonds, 1 double bond. Okay. On this one here, I can see 1, 2, 3 clouds, which means that, and the fact that there's no atom on the end of the lone pair doesn't change the fact that it's going to be repelling the 2 bonds, which means SO2 is going to have those 3 clouds sitting in this triangular format, right? However, one of these clouds does not have an atom on the end of it, so essentially in the shape you can't see it. Okay, so SO2 is going to have the three clouds that look exactly like this, except when we look at the atom, there's nothing on the end of one of those clouds, so you can only see that much. Okay, it looks like someone's come along and sort of folded it in half, and they've turned it into a bent shape, which is why we call it a bent shape. So someone's head's in the way. Is that better? What you'll notice is that the reason why I kept these two on the same page is that 3 electron clouds are on the central atom and 3 electron clouds are on the central atom. Okay, so the first step of the shape is total number of electron clouds on the central atom. Okay, remember, double bonds still count as one cloud because it's just 4 electrons in the same place. Okay, it's just a bigger cloud, I guess you could say. Okay, so all of those have a electron arrangement which is based on this. Okay, I would say the top one has got a trigonal planar electron arrangement, and because there's bonds on all 3 points, a trigonal planar shape. Stop spinning. Okay, this one here has a trigonal planar electron arrangement, but because one of those is a lone pair, it doesn't count for the final shape, so you have a bent shape. Last set, these guys. Okay, CF4 looks like that. Okay, it's got 4 bonds. One of the words that's used to describe 4 is tetra. It makes like a 3-sided sort of like, it makes a shape, so we call this a tetrahedral shape. Alright, if I go across to the NCl3, what I realize is that there's 1, 2, 3, 4 clouds, 1, 2, 3, 4 clouds. Okay, so in NCl3, you're going to have your 4 balloons. Again. Let's grab onto them. So those 4 clouds are going to go like that, right? The 3 tripod legs at the bottom, 1 balloon sticking straight up. But remember, one of these doesn't have an atom on the end of it, which means for the overall shape, you're not actually going to notice it. Okay, so this pink balloon is essentially going to be invisible for the overall shape. However, it still makes everything form this arrangement. Okay, so NCl3 is going to be the 4 electron cloud tetrahedral arrangement, but actually one of them has gone missing, which means we actually get, it really is, it's a camera tripod, right? It's like a pyramid. Okay, it's got 3 bonds. What was the word for 3 bonds? I'm pretty sure it was trigonal. It's now shaped like a pyramid, so that's called a trigonal pyramid. Sometimes people put people put trigonal pyramidal. It doesn't actually really matter. Trigonal pyramid is fine. Trigonal pyramidal is the same thing. Okay, and then H2O. How many electron clouds? 1, 2, 3, 4. 4 electron clouds. They're going to sit just like that. Same for everything on the whole page, right? However, you can't see 2 of these because there are no atoms attached. So we have to take them off. And all we're left with is this, like a Mickey Mouse face. Okay? And the thing about that is that it looks like it's been bent. So that is the bent shape. And that's actually all of the shapes that you guys have to worry about. Okay? If I was to, we could sort of make like a little summary almost. Is that all making sense to you guys? I'll tell you what, I'm actually going to make you guys work out some shapes yourselves. I'm just going to put them on a whiteboard. Alright, I'm going to give you your Lewis structures, and all you guys need to do is look at them. Think about the so sort of 2 bits. Okay, I want the number of E minus clouds on central atom. Okay, and then I want the shape name 1, 2. I'm not sure if that's going to show up that well. Probably will if I put it more there. Okay, I'm giving you the Lewis structures. One thing that's a little bit strange about one of these Lewis structures is that B doesn't have a full outer shell. It hasn't got 8 electrons. Boron is actually kind of okay with 6, so it just rolls with it. Okay, so it's not a mistake in the Lewis structure. A couple of years ago, that was in the final exam, and heaps of students were putting up their hand in the exam and telling the examiner, oh, but there's a mistake in the test because it doesn't have 8. It is what it is. Okay, so if you're supplied with a Lewis structure and if it doesn't quite make the sense of the rules, don't worry about it. Okay, you won't have to draw a Lewis structure that breaks the rules, however. Okay, so I'm going to give you a couple minutes. I'm going to go grab a drink of water and so on and so on. And give me number electron clouds for each one. We can call them A, B, C, D, and E. And then it's like, what would be the name of the shape? Okay. And I'll show you the DIY version of building these guys. It's going to require some sort of fruit or potato or something, and then some spiky objects. You'll see. Alright, how are you getting on? Is that about enough time, you reckon? Just let me know in chat. You're all good? Two E minus clouds. We can go through right now. You happy to go through the answers? Yeah? Alright. First one. 3 electron clouds, BF3. So I'm going to pick that, okay? Because that's as far away as 3 electron clouds can go from each other. Okay? And all of them are bonds, which means the actual shape is this, okay? When you look at the shape of the molecule, you can only really see where the atoms are, okay? Because there's an atom on the end of every one of these clouds. You see the whole thing. It's 3 bonds, trigonal, and it's also looking pretty flat, planar. The reason why planar is flat is because a plane is a flat surface. Okay, it's just a language thing. The next one, 4 electron clouds. So I'm going to choose this. Those 4 electron clouds sit in what I'll call a tetrahedral arrangement. Yeah. However, I'm not going to see one of those clouds in the final shape because there's no atom on the end of it. Okay, this lone pair, no atom there, won't show up in the overall shape, which means what I see is this. I've only got 3 bonds, but it's no longer planar because it's like a pyramid. Okay, so it's trigonal for 3 bonds, trigonal, and then it is pyramid, trigonal pyramid. Okay, the next one, I look at O3 and I see 3 electron clouds. The electron clouds sit like that. Okay, a trigonal planar arrangement. However, one of them is a lone pair, which means for the overall shape, it's hidden from view. So what I've got left is just that. 3 electron clouds with a trigonal planar arrangement. Only 2 bonds means all you see is the bend shape. CO2, pretty simple. 2 electron clouds. As soon as you only have 2, all you can have is 2 electron clouds on the opposite sides of each other. Okay, they sit in what's called a linear arrangement. Okay, and because they're bonds, I see the whole thing. Overall, the whole thing is linear. And the last one, 4 electron clouds again. 1, 2, 3, 4. So those clouds will sit like this. It's like having the 4 balloons. However, lone pairs with no atoms on them, they're hidden from view in the structure, which means I have to pull off a couple of these guys. And all that's left that's visible is that. So I'm going to say 4 electron clouds, But if only two of them are bonds, what I see is a bent shape. And that's it. Okay, there actually aren't, I mean, it probably looks daunting. What you find is that there is actually a lot of repetition in this. This O3, ozone, is actually the same as SO2. This is actually the same as H2O. This is the same as CH2O from the first example, and this is the same as, I think we did NCl3. Okay, so there are actually only, I think there's 5 shapes in total. And all you got to do is find the main patterns. Okay, step 1, count the total number of electron clouds. And then think about which ones are bonds and which ones are lone pairs. You only see bonds in the final structure. SH2, Daniel? Yep. Remember with SH2, I'll take off the beads just for the purpose of this. Okay. What I'm doing, step 1, electron clouds. 1, 2, 3, 4. Remember, what you draw on paper is deceptive. It's drawn in a straight line because that's the easiest way to do it. But that's not actually how they're going to sit, okay, necessarily. Okay, so 4 electron clouds repelling each other, they're going to make this shape, okay, this tetrahedral arrangement. However, only 2 of those electron clouds have got atoms on the end of them. The other 2 don't have anything on the other end of them, which means when you look at the overall shape of the molecule, it's like they're invisible. Okay, they're still there. They've caused it to have 4 electron clouds to give it the shape it has, but all that's left is that. Okay, I guess what you could think about is that one of the earlier structures you guys did was, we did one, I think it was CF4. We had 4 bonds, no lone pairs, and we got tetrahedral. NH3 is like the same base molecule, and pull this off, and that's what I'm left with, NH3. Okay, trigonal because there's now only 3 bonds, pyramid because it's shaped like a pyramid. Okay, and then I'm going to pull off one more bond to make it H2S. Okay, there's still 4 spots in every one of these because it's got 4 electron clouds. That's where the bent comes in. What I will do is I will show you as a final thing. I will show you guys. Let me just get back over here so it will actually change slides. Yeah. I will show you. Is it loaded in on this one? No. Okay. Let me just get out of there. I'll show you a quick little animation, and this is linked into the file that I posted just before. It's a PhET simulation. I'm pretty sure you would have used some of these before. But you can build the molecule on your screen and spin it around and do all sorts of things. Okay, I don't want the new ones, I just want all of them. Alright, don't be like that. That's better. Molecular shapes. Okay, if you just Google PhET molecular shapes, it comes up. I'll quickly show this, and then if you want to head off to your other class thing, that's all good. So what you can do with this is that we can turn on both of these. Molecule geometry just means shape. Electron geometry means how the 4 clouds are shaped. Okay, so if I wanted to make H2S, I have to have 2 bonds and 2 lone pairs, and it looks like that. Yeah? And if you think about things, that is our CF4 from one of the very early examples. Okay? If I spin it around so it kind of looks, you can grab things and pull them around. There we go. That probably looks, that's probably about how I actually draw it on paper, almost. So this guy's falling over a bit. Get back up there. There you go. Okay, these two are pretty flat. This one's pointing towards me. That one goes behind. Yes, so electron geometry, what you'll do is that if you find on the notes file, we call that the electron arrangement. Yeah, so this is just made by someone else. So we say electron arrangement, molecular shape. I think we all probably we all going to do that. Okay, the SciPad actually calls it electron shape and molecule shape, which I don't like because you shouldn't use the same word for two different things. Okay, so that is the tetrahedral shape of CF4. If I made it the NCl3, then one of those bonds just gets subbed in for a lone pair, and I end up with that. And what I've got is basically the same thing with the head chopped off, haven't I? Yeah? So it's still a tetrahedral electron arrangement because there's 4 electron clouds, but you only see 3 bonds, trigonal pyramid. If I zap one of those back and put it into a lone pair, there is the bent shape for H2S rather. Okay? Still 4 electron clouds, so it still has that same arrangement. Okay, in fact, if I spin it down, there we go. That looks pretty much like the CF4. Okay, but of course, you know, the easiest way to look at it would be around that way. What you can do with this is that there's an extra thing that gets tacked onto this, which is called the bond angles. You can turn on the bond angles on this, and you can waggle it around, and what will happen is that it'll automatically snap to the right position. Just one other thing with this is that you can actually build some other shapes that are in level 3. Like you can put more stuff on things and you get these extra names. Okay, don't worry about anything that's got more than 4 electron clouds. So this guy here has got 6 electron clouds. That's not important for us this year. Alright, and that's pretty much going to be us, I think. Unless anyone has any remaining questions and they want to type them in chat. I will, as a final thing, I will bring up the notes file, because the notes file gives you a structure for how you actually, what you actually write in your exam. Okay? I'm just going to bring it up on my second screen and flick it across. There it is. All right. So on the checklist that was sent out to you guys, there's some things inside this for you to fill out as you go along. Okay, so there's a bunch of stuff that we talked about today, the stuff here and the stuff here, and this is what you do in an exam. Okay, and the idea is that SO2 is a pretty good example for this actually. So maybe have a go at doing this just in your own time. Okay, and what you need to do is do one box at a time. Okay, there's a series of slogans that you essentially just piece together, and it gives you the explanation. Right? So you draw the structure and you say there is something rather electron clouds around the central atom. Okay, and then you'd say the clouds repel each other as far away as possible and sit in something rather arrangement. Sit in a linear arrangement, a tetrahedral arrangement, a trigonal planar arrangement. They're actually the only 3 answers. That's for 2, 3, or 4 clouds. Okay, and then you look at it and you say, oh, a certain number of those electron clouds are bonds and a certain number are lone pairs. And then as the overall shape only takes the bonds into account, the molecule therefore has a blank shape. Okay, so if you use that template, there's a couple of examples. There's SO2 at the top, and you can use the template and fill it out in the template, and then you essentially create your own answer for that one, and you create your own answer for that one. Once you've done those things, there's no reason why you can't actually then just move away into the bond angles at your own pace. Okay, and the final point is this. I did say that maybe if you're still struggling with this stuff, if we're in class, we would get you guys to play with plasticine and try and build these things, but obviously we can't do that. If you have plasticine or Play-Doh and kebab sticks or toothpicks, this would actually work, but probably not many people have those. But I've got like a gold kiwi fruit here. And the thing about this gold kiwi fruit is that I bought it in a box, and there's heaps of them, and they're all it's like made out of concrete. And I bought them obviously before the lockdown and everything. Like, it was even on the weekend, I think. And it just isn't going to get ripe, I don't think. So I'm going to perform voodoo on this, is what I'm going to do. Okay? Because what my voodoo could be is that I can have some sort of spiky objects, and well, I can try and build what I'm expecting. Poor kiwi fruit. I'm expecting the electron clouds to be like. So if I look at it and say, oh, it's a tetrahedral arrangement of electron clouds, I can stick a bunch of my toothpicks, or in this case, nails, inside it, and I can make it so it's like a tetrahedral arrangement. It's like a little moon lander kind of thing. Although it's kind of falling over. Okay, and then 4 electron clouds looks like that, and then I would say, oh, but 2 of these are lone pairs, and the other ones are bonds, in which case I'm not going to notice the lone pair ones, so I'm actually going to pull them out and just put like a little tiny little stub inside there. I'm going to pull that one out, put a little tiny little stub inside there. And then I think about what's left, and I see that the shape is bent. Okay, this would obviously work better if my kiwi fruit was round rather than being some sort of crazy oval thing. But I don't know. It might. It's like a face. It might be helpful if you try that. So the document that has that is posted on your classroom. That document also has a link to the FET animation, which might help you guys. Okay, but I think we should sort of leave it there. And there's on that document that was posted for work for this week. I don't really expect everyone to have finished all of it, because in a lot of ways there's sort of too much for a whole week. I'm suspecting you might get like a little bit bored, to be honest, over the next couple of weeks. I know I will be. So there's plenty of stuff on there that can keep you going. Okay. The next section of this is called polarity of molecules, and work has been set for you guys to work your way into that. It is something which it takes a while for students to really get their head around, but if you could do that, and then when we're sort of back online on Wednesday the 15th or whatever the day is, we'll pick up polarity from there. But it's much easier, I think, to do this stuff if you already have at least a bit of a handle. Because things are going to be way less interactive online than in class. What I'm thinking of might doing is that I might possibly run a Zoom alongside the YouTube Live. I'm using the YouTube Live because it will auto post the videos for everyone who's offline, but it's really hard for you guys to interact. Okay, so if I make a Zoom run side by side with this, it means you can use the Zoom and you can just yell out your questions at me, and I can answer them on the spot, as opposed to having to type stuff in. Okay, so is this a good point for everyone for us to finish on, or if there are any questions, do you want to quickly type them into chat? And I don't think I should eat this anymore. Although I don't think it was ever going to go ripe. I think there's something funny going on with it. Yeah, I know, but YouTube will record, and the live link is the same as the replayed link for YouTube. So it's just much more. I don't know. I find it much easier to use, and also I can with YouTube. I can change these things at will, whereas my Zoom, it just doesn't want to do all these things. No questions? Okay, so we'll cap it there, and I will see you guys in a couple of weeks. Okay, so stay safe and try not to go too crazy from being locked up, and yeah, just keep yourselves busy. Right, and I'll see you later on.